Good morning students. So myself Akshay Mahendrakar and we were in discussion with fluid dynamics. Clear? So in this today's class we are going to discuss one more very important law which is known as Torisilius Law, or we are going to determine velocity of a fluid, okay, which is coming out from a tank or something of that. If for a tank in between somewhere, if we make a hole, means with what velocity it is going to come, that thing we are going to discuss. Clear? So speed of this is also known as Torisilius Law. Clear? This is also known as Torisilius Law. So speed of efflux we are going to study now. So imagine that here we are having a tank which is filled with what? Liquid. Okay, we are having a tank. In this tank it is filled with completely liquid. And let us suppose until this point liquid is present. Yeah. And at this point somewhere in between here we have an outlet like this, and it is completely filled with, first of all it is filled with completely liquid. Okay. So from this point liquid is going to come out, and in this manner it will be coming out. Correct now? So what are the things we are assuming here? First of all, this V1 is nothing but velocity of the liquid which is coming out from this point. Okay, V1 only we are going to calculate. Next, at this free surface velocity will be equal to what? 0. That means it is steady liquid. Clear? And let us suppose from this complete basement, okay, from here to this outlet wall, let this distance be y1, and from base to complete free surface, let us assume this as y2, okay, and distance between outlet and free surface is nothing but h. Clear? From bottom of this complete vessel to outlet is nothing but what? Y1. From bottom to complete free surface is y2. From outlet to free surface is h. Okay. So from Bernoulli's theorem, so what we were having the equation number A. So what was that equation? P1 plus half rho V1 square, correct no? Plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. Now first of all let us see. Here value P1, here value P2. Okay. On both the sides atmospheric pressure is acting, which is nothing but what? PA. So if I substitute here P1 equal to P2 is equal to PA, means P1 P2 will get cancelled. That means PA will get cancelled. Okay. Next, substitute P1 is equal to P2 is equal to what? PA. Next, at this point velocity is 0, that's why V2 is equal to 0. We are going to substitute P1 is equal to P2 is equal to PA, which is nothing but what? Atmospheric pressure. Next, V2 value at the free surface 0. V1 we are going to calculate. Next, put H1 is equal to Y1, that means this distance, and H2 is equal to what? Y2. Yeah? So by substituting these values, let us check. Here what I can write? PA, correct no? PA plus half V1 square plus rho G H1 plus rho G in the place of H1 Y1, yeah, is equal to, second case what we are having, P2, which is nothing but what, PA, clear, plus half rho V2 square plus rho G Y2, yeah, plus rho G Y2. So atmospheric pressure will get cancelled with what? Atmospheric pressure. What are the things remaining? Let us see. First of all what we are having here, half V1 square, here rho G Y1, here half rho V2 square, rho G Y2. V2 value we are going to substitute what? 0. That means this term will become what? 0. So what is remaining? Half rho V1 square is equal to rho G Y2 minus rho G Y1. Rho G Y2 minus rho G Y1. So here what I can write, half rho V1 square is equal to, here what I can take common, rho G Y2 minus rho G Y1 means rho G I can take common, if correct now, rho G common if I take means what is remaining in the bracket, Y2 minus Y1, clear, Y2 minus Y1. Next, half rho V1 square is equal to, rho we can cancel, okay, rho we can cancel, so half V1 square is equal to G into, what is Y2 minus Y1 from the diagram? This complete totally it is Y2, this is nothing but Y1. Y2 minus Y1 is nothing but this distance. This is nothing but what? H. Correct? No? That means from this outlet until this free surface. So what I can write here? GH. Okay? So V1 square is equal to 2GH, or V is equal to, sorry, V1 is equal to root of 2GH. That means this velocity, okay, speed of efflux, this is known as efflux. So speed of efflux is equal to root of under root 2GH, okay, and it is identical to a equation of free falling body. Clear? For free falling body also you will be going to get same kind of equation. Clear? So this is also known as Torisilius Law. Torisilius Law. Yes, same thing. So first of all, what we had assumed? We had assumed a tank which is filled with liquid, okay, and which is having an ejection, or what we can tell an outlet over here. And first of all, it is completely filled with what? Liquid. And from this output wall, the water will start flowing outside, okay. Then from this bottom or from this base of the vessel to this outlet, we are considering it as what? Y1. Okay, it is nothing but what? Y1. And here Y2. Next, that means Y2 is nothing but what? From this bottom of this complete vessel to this atmospheric free surface. Next, from this outlet to free surface, we are going to consider it as what? H. Clear? So just we had applied Bernoulli's theorem or Bernoulli's principle. We have P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. So here what we had substituted, this is substituting. Clear? Substituting P1 equal to P2 is equal to PA. Why? Atmospheric pressure is acting. Next, V2 is equal to 0. This is nothing but what? Steady case. Okay, V2 value will be equal to what? 0. Next, what we are having here, H1 is equal to Y1. That means this value we are putting it as h1, in this equation h1 value we are going to put it as y1, next h2 value we are going to put it as y2. So just we solved, easy mathematical steps are there, you will come to know. Okay, finally you are going to get what? V1 is equal to root of 2gh, clear? And remember it is independent of this radius of this output wall, clear? So this value will be what? Constant value under root 2gh, clear? Shall I erase the board? Clear? Shall I erase the board? Okay. Okay. So next we are going to discuss about Venturi Meter. Listen, this Venturi Meter, it is nothing but a simple device used to measure speed of an incompressible fluid. What is that? It is a device used to measure speed of an incompressible liquid or basically fluid. So Venturi Meter, it is a device used to measure a speed of incompressible fluid. So what do you mean by incompressible? Which doesn't get compressed, correct? No, that means a delta V value will be equal to 0. That is nothing but that we are going to treat it as what? Incompressible. That means it doesn't get what? Compressed. Okay. So it will be having a horizontal pipe, okay, in this shape. This pipe will be having 3 parts, part A, part B, part C. Clear? This is A, this is B, and this is C. A and C are having broader necks. Clear? Broader cross-sectional area. C as well as A. That means this is also broader one, and here this is also broader. And here it is nothing but very small cross-sectional area. This is known as constriction. Okay, which is having a very small cross-sectional area. This is known as constriction. Clear? From this constriction, okay, one pipe is connected in this manner. A U-shaped manner, a tube is connected in this shape. Clear? So inside here, okay, one more different material or a different liquid will be present over here. Yeah. Now fluid is passing in this manner. These are nothing but what? Streamlines. Okay, the path followed by the fluid is given by what? Streamlines. Streamlines will never intersect each other. Remember. Okay, here they are not intersecting. Okay. Okay. So here I have now drawn this on streamlines. Okay, and this is what? This is nothing but a U-shaped tube which is connected. One end is connected for this constriction part, and one more end is connected at this broader neck part. Clear? So from equation of continuity, what we know? What is basically equation of continuity? Equation of continuity is nothing but rate of fluid flow will be constant. That is nothing but A1 V1 is equal to what? A2 V2. Okay. So here we are having cross-sectional area capital A, okay, and velocity is small v1. Here cross-sectional area is small a and velocity is v2. Okay. Shall we proceed? So A, first I will mention from equation of continuity. Okay. A1 V1 is equal to what? A2 V2. So substitute the values. A1 is nothing but A, V1 is V1 is equal to A2 is small a, V2 is V2. So from this expression, just keep V2 as separated value. V2 is equal to A V1 whole divided by small. Yeah. Next, from Bernoulli's principle, we have set of equations, correct? No? So in those set of equations, we are going to choose equation number A, okay, which we had used in our last class, which we had derived. So what was that? P1, okay, plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. Clear? So P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. Okay. So now concentrate H1 and H2. That means from the base, this point, okay, it is at some height, and here also height is same from the ground level. If we are considering, means that's why what we are substituting means H1 is equal to H2 is equal to same height H. That means this two H1, that means rho GH1 as well as rho GH2 will get what? Cancelled. Okay, now what is remaining? Let us check. P1 plus half rho V1 square plus rho GH, because we are substituting H1 is equal to H, is equal to P2 plus half rho V2 square plus rho GH. So basically rho GH will get cancelled. What is remaining? P1 plus half rho V1 square is equal to P2 plus half rho V2 square. So difference in pressure we are calculating. First of all, basically P1 minus P2. So if I want P1 minus P2 means what I can write? P1 minus P2 is equal to P1 minus P2 is equal to half rho V2 square minus half rho V1 square. Okay. Now this V2 value we are going to substitute here. So if I substitute V2 value means what I will get? P1 minus P2 is equal to half rho V2 square means A V1 by A square square square, because it is V2 square, minus half rho V1. So what all the things are common? What all the things are common here? Just you can check. Half rho V1 square V1 square. Clear? So P1 minus P2 is equal to half rho V1 square. Half rho V1 square. Inside the bracket what I can write? A square by A square minus half rho V1 square, half rho V1 square, it is common, minus 1. So P1 minus P2 is equal to half rho V1 square into bracket A square by small a square minus 1. Due to this pressure difference, what will happen means the fluid which was earlier we were having, okay, it will just get, that means this pressure will push, and here somewhat this level will increase, here somewhat this level will decrease. Clear? So if it is decreasing until this point and it is increasing somewhere over here at this point, means distance between these two levels is nothing but what? H. Clear? So now Shall I erase this part? We'll proceed again. Still some small derivation is there. After this, only few steps are remaining. Clear? Okay. So what we had arrived, P1 minus P2 is equal to half rho V1 square into A square divided by A square minus 1. So due to this pressure difference, what will happen? Liquid in that U2 will somewhat, it will get shifted. So at that point in that U2, if we calculate P1 minus P2 means it is nothing but what? Rho GH. And here to specify it is of different density, I will use rho m. Clear? So basically these two equations we are equating now. So what is remaining? Half rho V1 square, okay, into bracket A square by A square minus 1 is equal to rho m GH. So here you can take LCM and shift, otherwise this complete quantity. Clear? So half rho, so apart from going for this step, directly we can write what we are having. V1 square is equal to rho m GH, okay, divided by this complete factor, but I will be mentioning it in numerator only, A square by A square minus 1. Yeah? And 2 and rho are remaining, so 2 is multiplied here, 2 rho m GH whole divided by this rho. Okay, this rho and rho you should not cancel, because this rho is nothing but what? Density in that U2 U-shaped tube, and this density is nothing but what? Density of fluid which is passing through what? Venturimeter. Okay, and next here we got actually V1 square. So if we calculate V means what we will get, sorry, V1 means V1 is equal to root of 2 rho m GH whole divided by rho. Yeah, and here this is actually minus 1 because it will shift to denominator. I am considering it in numerator. So what I can write here, A square by A square minus 1 whole power minus 1 into 1 by 2 means minus 1 by 2 by root. 1 by 2 is nothing but I am taking root here. Clear? So otherwise what we can go from this step? We can take LCM over here. Okay, let us see what we are going to get. Half rho V1 square into bracket A square minus small a square whole divided by A square is equal to rho m GH. Okay, V1 square we want. So V1 square is equal to rho m GH as it is. So A square will be multiplied here, it will become A square whole divided by this A square minus A square. Okay, and 2 will be divided to numerator, and in denominator we will be having one more row. So V1 is equal to, A will come outside from the root, okay, because it is A square, A into root of 2 rho m GH whole divided by A square minus A square into rho. Clear? So Venturimeter, it is nothing but what? It is a device used to measure speed of an incompressible liquid. Okay. First step you will be going to use equation of continuity. Okay, which is nothing but what? A1 V1 is equal to A2 V2. Next, after that, you will be considering about Bernoulli's principle. Okay, Bernoulli's theorem, that complete definition. Okay, sum of pressure, and kinetic energy per unit volume, okay, potential energy per unit volume, that addition will remain as constant. Okay, in that we will be having two set of equations, actually more than two set of equations, but major equations I had named on those as equation A and equation B, correct now? So from that equation A, you will be substituting what? The values of whatever the things you are going to get in Venturi Meter initially. That means from the equation of continuity you will be getting V2 value. Okay, those all values if you substitute means finally you are going to get this step P1 minus P2. If you separate means half rho V1 square into bracket A square by A square minus 1. A is nothing but what? Capital A. It is nothing but cross sectional area of broader end. Small a is nothing but cross sectional area of that constriction end. Okay. Next, due to this pressure difference, what will happen in that U-shaped tube? Okay, due to this pressure difference, that liquid will rise again on the constriction side. It will just rise again. Why it will rise means at constriction what will happen? Cross sectional area is completely minimum first of all. So if cross sectional area minimum means what will happen for the pressure? Pressure value will be minimum, correct no? If completely velocity is maximum over there, if velocity is maximum means what happens for pressure according to yesterday's Bernoulli's equation? It is nothing but what? Even inversely related. Okay, so that's why the liquid will shift. Then this equation P1 minus P2 is equal to rho mgh. This is specially for U-shaped tube. Okay, pressure difference in that U-shaped tube if we calculate means rho mgh. Rho m, this m signifies as density of the material which has been used in that U-tube. Clear? Next, these both equations having the same left hand sides. That's why we are equating right hand sides. So if you equate right hand sides means if you have not taken here LCM means one set of format you are going to get. If you take LCM and solve means you will be going to get one more set of equation. Clear? Both are same only. Both will give you speed of that incompressible liquid only. Clear? So keep studying. Again we are going to discuss it in our next class. Thank you.